Welcome back. Today we are going to look at solving systems of equations algebraically. Yesterday we started looking at solving systems graphically, and today we're going to look at one of the two methods for solving them algebraically. This is a method called substitution. It's where we solve one equation for one of our variables. In other words, we get a y by itself or we get an x by itself. And then we can substitute that expression into the other equation. That eliminates one of our variables so we can solve for the remaining one, and then we can plug our answer back into our original equation in order to check and get the second variable. All right, so our first example, we have the system y equals 2x plus 1 and 3x plus y equals 11. Notice that our first equation is already solved for y. So basically we are saying y is equal to 2x plus 1. That means we can replace that y in our second equation with that expression. So our second equation becomes 3x plus, and instead of a y, we're going to replace it with this 2x plus 1 equals 11. We've done a substitution. And now notice that there's only one variable left. There's just an x. So we can combine our x's into 5x plus 1 equals 11. Solving for x, we would subtract a 1, and then we would divide out the 5. So we end up with x equaling 2. Then to figure out our y value, we do another substitution. We're going to plug this back in to our first equation. So y equals 2 times what we've now found x to be, plus 1. So y equals 4 plus 1, or y equals 5. So our ordered pair, the point where these two lines would cross if we had graphed them, would be at the point 2, 5. Our x-coordinate was 2, our y-coordinate was 5. All right, our second example here, again, we have one equation that's already solved for y. We are going to make a substitution, and in place of our y, we are going to replace it with this x minus 4. So notice here that this y is going to get replaced. We're going to substitute something in there. So my second equation was 2x plus 3 times my y value equals 7. But now I'm making that substitution, and I'm putting an x minus 4 in there in place of y, since we are told that y equals x minus 4. Now I can simplify this, distributing. Combining like terms, we'd have 5x minus 12 equals 7. We can then add the 12 over. We've got 5x equals 19, and we end up with x being 19/5. All right, now we have to take that x value of 19/5 and we have to plug it back in to figure out our y-coordinate. So y equals 19/5 minus 4. And we can convert that 4 into a number with a 5th, so a 5 in the denominator. By multiplying this 4 over 1 by 5, we'd get 20 divided by 5. That's equivalent to a 4. When we subtract, we've got negative 1/5. So our ordered pair would be 19/5 for x and negative 1/5 for y. Remember, we can take those and plug them back into our original equation to double check them. Don't forget, sometimes we have to solve for an x or a y. In our first two examples, it was already solved for us. But on this one, we don't have an equation that has a single x or a single y all by itself on one side. But we can do some rearranging. I do have a single y right here. So let's rearrange this first equation. I'm going to subtract the 2x to the other side, and it looks like this. So y is equivalent to negative 2x plus 1. I'm going to take that and substitute it in for my y value. So I have 2x minus 3 times what I'm substituting in equals negative 27. And we said we're substituting in a negative 2x plus 1. Distributing, we end up with a positive 6x minus 3 Combining like terms, we have 8x minus 3 equals negative 27. We can add 3 to the other side. We now have 8x equals negative 24. And then dividing, we've got x being negative 3. And then again, we are going to dump that in to figure out our y value. So y equals negative 2 times x plus 1. We just found x to be negative 3. So we get a y value of 6 plus 1, or 7. So my ordered pair would be negative 3 for x and 7 for y. For our fourth example here, we have a single x right here. It is a negative x, but we can deal with that. So I'm going to take this first equation, I'm going to subtract my 2y to the other side. So I have negative x equals negative 2y plus 13. And then I can divide out my negative. If I divide everything by negative 1, I have x equals positive 2y minus 13. And now I can substitute that in, but since I solved for an x, I am going to substitute that in for my x variable here. All right, so we have 2 times something plus 5y equals 10. I'm going to make that substitution and dump in a 2y minus 13 since x is equivalent to that. Distributing, we get 4y minus 26 plus 5y equals 10. Combining like terms, we have 9y minus 26 equals 10. Adding 26 to the other side, we have 9y equals 36, and when we divide out the 9, we get y is 4. And then once again, I'm going to substitute that back in to find my x. X was 2 times y minus 13. We're going to dump that 4 in there. So we end up with 8 minus 13, which would be negative 5. So my solution here, my x coordinate is negative 5. My y coordinate is 4. That would be my solution, my ordered pair, where those two lines would intersect. Don't forget our special cases when the variable cancels out. We have an infinitely many solution as our answer if we are left with a true statement. We have a no solution if we're left with a false statement. So looking at this, if we go to make a substitution, y is equivalent to 4x. So I'm going to replace my y with a 4x. We have 8x minus 2 times what I'm dumping in equals 3. We're plugging in a 4x. And when I do this, I get 8x minus 8x equals 3. So 0x equals 3. And if I try to divide by 0, I can't. We aren't allowed to divide by 0. It's undefined. So there is no solution to this one. There's no value that for x or y that would make that system true. These are parallel lines. They will never intersect. All right, so if your variable disappears, you have to look at whether you have a true statement. 0 does not equal 3. So we have a false statement. There's no solution.